In this video, I'm going to walk through the basics of the labor discipline model from Chapter 6 of the Economy for you. So the basics of the labor discipline model sort of revolve around this idea that the employer can't directly model the worker's effort and only get indirect or incomplete information about it. In other words, there's a principal-agent problem involved, and the worker's effort is an action that's hidden from the employer. To that, we add the idea of employment rent, which is that workers value staying in their jobs more when they're, for example, paid more, or if the level of unemployment benefits is low, or if they have, say, a particularly good set of amenities there that it would be hard for them to get elsewhere. So the higher those employment rents, more workers are going to value staying in their jobs. And if employers are more likely to fire workers who put in low effort, say because they can observe effort after the fact with some probability, so they can't observe it perfectly, but they do get some information about it, then because they're able to fire workers who have been observed to put in low effort, workers who value keeping their jobs are going to put in more effort, and they'll value keeping their jobs when the employment rent is higher. Therefore, one way for the firm to get workers to exert effort is to have higher wages, and having higher wages increases the cost of job loss for the worker and makes the worker not want that to happen. So we use some of the concepts of game theory from Chapter 4 of the Economy to develop the labor discipline game, although this game looks a little bit different from the ones we saw in Chapter 4. And so the model is one where firms are going to choose wages, so they're going to give the employee an offer of a wage. The employee will then decide how much effort to exert given that wage, and if the level of effort that the employee has exerted isn't what the employer expected, they can fire the worker. This happens in each of a series of periods, and so the labor discipline game is a sequential game. The components, we have two players, the employer and the employee. The employer offers a wage W, as I said before, and I'll kind of go over these primitives a couple of times just to make sure that we kind of get them down. So the employer has a strategy of offering wage, W, that can be, any positive number. The employee then, seeing W, decides how much effort to exert. That's their best response, a concept from Chapter 4, their best response to that wage offer. And then the employer has the last move and can decide whether to keep them on or fire them. Okay. The payoffs for the employer is the output of the worker, which we don't talk about explicitly, minus the cost of employing the worker. So in other words, the explicit part we talk about is the cost of employing the worker. So employers' payoffs are going to be falling in that cost. They're going to want to employ workers as cheaply as possible. The payoff for the employee is their employment rent. So we sort of start in the middle here with the employee's best response function, so sort of part 2 in this 3-part sequence. And so one thing we know about the employee's best response is that if their reservation wage is equal to the wage that they are offered by the employer, which is $5 an hour here, they're not going to exert any effort. Why is that? Well, if there's no employment rent, that means that the employee is indifferent between keeping their job and losing it. We can think of the situation with no employment rent as one where immediately after being fired, the worker can go out and get a job that is just as good as this one, or as a situation in which the unemployment benefits and say other income that they might get from family support and so forth would be exactly equal to the wage that they would get if the employer offers them the reservation wage. So if the employer offers them the reservation wage, it doesn't make any sense to exert effort. The best response curve, which is this blue line here, says that when employers offer wages above the reservation wage, so here more than $5 an hour, the employee is going to exert some effort. That's because if the wage that's offered is above the reservation wage, there's going to be some employment rent, and employees are not going to want to lose their jobs, so they will exert some effort. So employment rate rises with the wage that's offered, and so it makes sense that this blue best response line is going to slope upwards. It's curved because when more effort is being provided, adding additional effort, we're going to say, is a little more onerous than when a low level of effort is being provided. So you can imagine that sort of going from 20 to 30% effort doesn't have, say, a very high disutility associated with it, whereas going from 80 to 90% might. The slope of the best response function we're going to call the marginal rate of transformation. And at any particular wage, that just says for another $1 of wages, how much more effort can I get out of an employee? And you can see that that slope will be low when we're have a wage that's close to $5 an hour. Rather, that slope will be high when we have a wage that's close to $5 an hour, and then it will be low when we have a wage that's close to $30 an hour. So the sequence, again, just to kind of get this clear in everyone's mind. So first, employer chooses a wage level W star, knowing what this best response curve, which we showed on the previous slide, looks like, but not the employee's actual choice of effort E. Okay, so the employer in particular can't condition what wage they're going to pay on the choice of effort in this period. So for example, they can't say, I will pay you 0 if your effort choice is 0, but I'll pay you $10 if your effort choice is 0.5, and I'll pay you $20 if your effort choice is 0.7. All that the employer can do is state a wage. And so this captures the fact that the action of the employee is hidden from the employer when they choose the wage level. Okay, step 2, the employee, seeing this wage offer from the employer W star, is going to use the best response curve, E of W, to determine their level of effort. And so that is mechanical. They're just going to use that curve like a lookup. They're going to just look up the level of E that corresponds to the employer's wage offer W star. And just parenthetically here, I'm calling these the level offered by the employer W star rather than just W, to highlight that it is the employer's best response to the employee's best response, which is this curve E of W. So they're going to select the wage that is the best wage possible for them, the employer, and we'll talk about what that is in a second. Third, the employer fires the employee if they don't give this best response level of effort. So if the employer says, I'm going to offer you the wage W star, and the employee doesn't exert the effort E star equals E of W star, so the corresponding level of effort to that W star, they'll get fired. And so since they don't want to get fired because they get employment rent, they're going to always exert E star. So this third part of the sequence of play is a possibility that ensures that the employee is going to exert E star, because if they didn't, they'll lose their job. And as long as that wage W star is above the reservation wage, it's never going to be in their interest to not exert effort. Okay. So, what is the employer's best response to this best response function of the employee? So maximizing profits means that the employer is going to want to minimize the cost of production. And in this setting, there's a trade-off between the wages that are paid and the effort exerted by the employee, and its effort that is going to produce the output for the firm. And so this is a really important point that can be a little bit confusing to understand, because we usually think of the input that employees provide as hours rather than effort. Here it's going to be effort. And when I explain the ISO cost lines for effort on the next slide, this should become a bit clearer. So we can measure the cost to the employer of a unit of effort as the wage divided by the level of effort, and say, suppose according to the employee's best response function that when W is $12 an hour, they exert 60% effort. So that means that employing this person for an hour for $12 gets the employer 0.6 units of effort, and it's those 0.6 units of effort that goes into making the good that's being produced. So this means that the cost to the employer for a unit of effort is $20. So you employ someone for 1 hour, you get 0.6 units of effort out of them, and you pay them $12. That's $20 per unit of effort. And so on the same graph that we drew the employee's best response function, we can draw a bunch of ISO cost lines that represent different costs of effort. So up along the top and going down the side here in red are labels for each of the ISO cost lines that says how much does the employer have to pay to get a unit of effort along that ISO cost line. So if we look, for example, at the ISO cost line that is corresponds to $30 per unit of effort, we can see that along the line there are different combination of wages and effort that yield a $30 cost per unit of effort. So for example, you could employ someone for $30 an hour, and if they gave a full unit of effort for that hour, you would spend $30 to buy a unit of effort. If we sort of go here, suppose that you paid someone $15 an hour, and for $15 an hour they exerted half a unit of effort. Well then, you would have to spend $30 on that person to get a full unit of effort, because you'd have to employ them for 2 hours, and in each of those 2 hours they would give you half a unit of effort, and you would add them up. That would make a full unit of effort, and it would cost you $30. So similarly, if we look at 10, the ISO cost line that corresponds to a cost of $10 per unit of effort. Here you could pay someone $10 an hour, and if at $10 an hour they were willing to put in full effort, you would spend $10 to buy a unit of effort. Or you could employ someone for $5 an hour, and if that person were willing to work at 50% effort for $5 an hour, then you would also be spending $10 per unit of effort, because you'd need to employ them for 2 hours. They would give 50% of effort during each of those 2 hours. You'd end up with a full unit of effort after 2 hours, and that would cost you $10. So the slope of these ISO cost lines indicates for us how much effort the employer gets per dollar spent. And so they're steeper for the ISO cost lines that are closer to the vertical axis. That means that the employers get more effort per dollar spent. For the ISO costs that are closer to the horizontal axis, it means that a dollar spent doesn't give very much in the way of units of effort. And so these ISO cost lines sort of show us what the best response of the employer is going to be. And in particular, what the employer wants to do is figure out a way to minimize the amount that they have to pay for effort. And they're going to set the wage that they're going to offer the employee based on the point on the employee's best response function that is associated with the lowest possible cost of effort. Okay. So here we're sort of putting the employer's ISO cost lines and the employee's best response function on the same graph. Let's start by looking at the cost of effort of $30 per unit of effort. So if we're going to pay $30 per unit of effort, we could say ask the employee to work here, which is at $26 an hour, or maybe it's $26.50 an hour, and they would put in something along the order of 85% effort. And then we could ask ourselves, is that the cheapest cost of effort we can get? Well, if you look, you can see that as we move down this best response curve, the cost of effort is getting cheaper and cheaper and cheaper. So here's 27.5, 25, 22.5, and then 20. And then the best response curve starts to intersect with higher costs of effort. So we hit 20 here, then we're back to 22.5, 25, and so forth. So 20 is the cheapest cost of effort that we can achieve in employing this person. And so that is our best response as the employer to the employee's best response function. We pick this wage level of $9.50 an hour, which has the employee putting in an effort level of 0.466, and we get a cost of per unit of effort of 20, and that's the lowest that we can get out of this employee with this best response function. And so here, we have the employee getting paid a substantial amount above their reservation wage. So they're getting paid $9.50 an hour. Their reservation wage is $5. So that means that they're earning some employment rent. This is called an efficiency wage. An efficiency wage means a wage that's set above the reservation wage to encourage employees to exert effort because they earn employment rent and don't want to lose their jobs. So in the labor discipline model, there is involuntary unemployment. Because workers are earning more than their reservation wages and exerting effort, they are having a positive sort of duration of unemployment. So if they lose their jobs, they're going to have to be out of work for a while before they get a new job. And so remember that employment rent is total employment rent is the rent per hour times the number of hours per week usually worked times the duration of unemployment. And so if the duration of unemployment were 0, the total employment rent would be 0, and then workers would not be interested in exerting effort. So in the labor discipline model, wages and involuntary unemployment have to be high enough to produce employment rent, and that ensures that workers put in effort. And this model is nice because in the real world we actually do observe involuntary unemployment at all parts of the economic cycle. So sometimes unemployment is high and other times it's low, but it's always positive. And the reason why that's the case is because of this hidden action problem in employment that leads employers to want to offer employees wages above their outside options, so they exert effort. And in order to do that, there has to be involuntary unemployment. So there are a number of factors that can move the employee's best response function. For example, the utility of things that the wage can buy might change. That could be, say, due to inflation or something like that. The disutility of effort may change. Perhaps the circumstances at work become more or less pleasant. The reservation wage can change, say because the duration of unemployment changes or the level of unemployment benefits changes. Also, the probability of getting fired may change. And so we're going to look at the third one here on the model, changes in the reservation wage. And so initially we suppose that the reservation wage is low. It's $2 an hour. And that means that the best response of the firm is to set the employee's wage to around $4.20 and have them exert something on the order of 0.33% effort. And so remember that the reservation wage is equal to the mean unemployment benefits per hour plus, which are U, plus Y, which is the income that you might get from family or other support, minus the disutility of unemployment. So say that what happens is that unemployment benefits become more generous. Okay, so with our initial low reservation wage, the cost of effort to the firm is $10 per unit. Now we suppose that the reservation wage rises to about $5 an hour. The best response function has shifted to the right. That means that the employer is now going to offer this person $9.50 an hour, and they'll work about 0.466 percentage of maximum effort, and the cost to the firm of buying a unit of effort is now $20 rather than $10. So this situation is better for the employee because they're getting paid more per hour, but worse for the employer because they're having to spend more to buy a unit of effort. Similarly, we can imagine the reservation wage rising to 7. If the reservation wage rises to 7, then the employee's hourly wage goes up to about $13.50, and they exert about 55% of maximum effort, and the cost to the employer of a unit of effort is about $25 now. So when the reservation wage rises, the employee's outside option is better. So initially it's only $2 an hour. In the end of this sequence, it's 7. This increases workers' bargaining power with the firm and leads to an increase in both wages and effort. From the firm's perspective, effort has become more costly to acquire, and so this is something that hurts the firm's profitability.